Hello, so today we are doing this problem called search in a rotated sorted array, and the problem essentially says that we get an array that is sorted in ascending order, and the goal is so it's sorted in ascending order and is rotated at some pivot position that we don't know beforehand. So for example, instead of getting this sorted array, we get it rotated at this position 0. And then we get a target value that we want to search, and if that target value is returned in the array, is found in the array, we want to return its index. Otherwise, we want to return -1. And we can assume that the array has no duplicates, and the complexity should be in the order of O log n. So we can't do a sequential search and find the element. So an example here is this array where we are looking for 4 and the position is 0, so we need to return we are looking for 0 in this array and the position is 4, so 0, 1, 2, 3, 4, and so we need to return that. Same thing for here, we are looking for 3 is not in the array, we return -1, and you can see each one of them is rotated here at this position. Okay, so let's see how can we solve this problem. So the array is sorted. So this hints to us that we should use binary. Okay, so we want to search in a rotated sorted array, and as soon as we see sorted array, we should directly think about using binary search. And so I have a video detailing how you can identify that a problem can be solved with binary search and how to use a template to solve using that method. And so that's what we are going to be applying here. I will put a link to the video in the description. Please check that out first and then come back to this. But the main idea is that we need to find two things. We need to find the predicate in the search space, but first we need to think about whether this problem can be solved by binary search. And basically, to do that, we need just to check that the function is monotonic and that it has some kind of structure where it's first the predicate that says can say first all false values, and then after that all true values. So let's first see how can we do that. But first thing you can see here is we get a sorted a rotated array. So we get something like this. So we get an array, let's say 4, 5, 6, 7, 0, 1, 2. So we realize that the first thing we can do is find the pivot index, because once we know that the rotation index is here, we can check if the target that we are looking for is on the left or on the right. If it's on the left, then we can search this portion with binary search again, because we know it's sorted. If it's on the right, we can search this portion because we know it's also sorted. And so that's the main idea, is to use binary search twice. So first find rotation index, using binary search. Then second, find target in either in 0 up to rotation, or in rotation up to the last value of the array, right? So it's either here or here, or maybe this one should be so basically just identify in which portion it is and then search there. And so this one is easy. The second one, this is just typical binary search, right, on a sorted array, right, the one that we are more familiar with. Here, what I will be considering an array is just the sorted portion, either this portion or this portion, right? So now the difficult part is finding the rotation index. How can we construct a predicate here for this case to be able to find the pivot index? And so one thing is we can think about is what are the properties of the pivot index here. Let's call it rotation here, rotation index. So how can we find any properties of it? So we know that the value at that position should be so we know it should be bigger or equal to 0, right? Sorry, it should be smaller than the first element, right? Because that's where we are rotating. So we put the small portion that was left to the first element, we put it to the right. And so should be smaller. And we know that the pivot also value should be smaller than the last value, right? And so now this is one of the property that we know about the rotation index. Now does this property, like once it's verified, so first it's not like verified, and then once we know it, does it still be hold true for the rest? Like if that property is true for 0, is it true for 1? So let's see that. So if this one is smaller than 4 and smaller than 2, the 1 here, anything in between it and the last element should be smaller than the first element, since that's part of in the sorted array, that section would have been here. And it should definitely be smaller than 2 because we rotate, but this portion here should be sorted, right? So this property is definitely valid here because anything after the rotation index has the same property as rotation index, because it should be smaller than the first element by definition, because this is the rotated portion that should have been in this. When the array is sorted, it was on the left, and it should be smaller than the last element, because that's by definition what the sorted array is, right? And so we know that we have this property here where first we have the predicate is false, and then it becomes true, and when it becomes true, it never becomes false after that. And when it was false, it never was true before that. Like we are rotating only once, so we never have a case where we have true here, because that means we rotated twice, right? And so now let's just explicitly write our predicate here. So the predicate here is that p of x. So x is here what we are looking for, which is the pivot. It's smaller than the first element, right? And it's smaller than the last element. So smaller than the first element and smaller than the last element. So this is our predicate, and once it's so what we are looking for is this position here. We are looking for this first true. So first or smallest, that's the pivot value for which p of x is true, right? And so now we can just go back to our template that we defined here for binary search, where we just need the low value, high value, and the predicate. We already know the predicate, so now we just need to know low and high and apply our template. And so what is the search space here? So search space rotation index can be any position in the array, right? It can be anything in the array. We can rotate in any position, and so the search space is all the values in this that have index in this range, right? And so that means that our low value starts out as 0 and our high value starts out as n-1, right? And so now let's just write the function, right? So the first function that we need to write is finding the rotation index, and then it's easy to write the second function to find whether the target is, to look for the target either on the left portion or on the right portion. And so first let's write this function called find rotation index. Okay, and we get an array, let's call it names, that's the input, and we get a target. And so we need a low and high value, and they start as 0 and n minus 1. First I'm going to define n as the length of the array, and we do the binary search template here, which is while low is less than high. So we need to calculate the mid, right? So mid is equal to low plus and then we check if px is true, and px is this, so that means we check if nims 0 is bigger, so p of mid, that's what we are doing, so nims of mid, if nims of mid is smaller than the first element and smaller than the last element, then either it's this one or another one in between after that, or it's really the first one. And in both cases it doesn't make sense to look here, right? Because those we know are true by default, and so we need to look to the left, because either that value is the first one, or maybe there is another true that is the solution. And so we need to look left, and so to look left we set high to mid, and we need to include min because that's maybe the last true, like the first true, right? Maybe it's actually this one. And otherwise we need to go to the right, because if it's false, so maybe if it's false, then maybe it's here, so there is no need to look here because those are false. Well, that's not what we are interested in, that there is no pivot in there. And we don't need to include the element we are at itself because we just want the first true. And so if anything is false, we can just discard it and look to the right of it. And so to look to the right of it, we just set low to be mid plus 1. This is the same template of binary search, and the template here says we check if low is solution, then we return the index. Otherwise we say -1 because maybe there is no solution even in the search space. And so how can we check if it's a solution here? We can just check if, so either it's the first element, so the pivot is the first element in the case where the array is sorted. So in that case we should consider that as a solution. Basically I consider if it's sorted, then it's if it's sorted like in ascending order, then its pivot position is the first element. If it's sorted in the reverse order, then its pivot position is the last element, right? And so if one of these is true, or the pivot position is inside the array, then it has to be that. So if this is the pivot of like in the array we have something like this. So it has to be smaller than the element before it, and it has to be bigger than the element, sorry, it has to be smaller than the element before it, and it has to be smaller than the element after it, right? And so it should have the property, to be a solution, it should have the property that it's smaller than the element before it and smaller than the element after it. Otherwise it's not true. Or it's one of the boundaries, for example in the case of 3 1, this one is the pivot is 1, and so there is no element after it, so we can check against that. Or it's 1 3, in this case it's sorted in ascending order and the pivot position is just like the first element, right? And so now if this happened, then we know it's a solution and we have a pivot index. Otherwise we don't have a pivot index, and we return -1. And so this is the finding the rotation index. Now the usual binary search for just looking for an element, that's easy to write. I'm going to omit it for now, but the core of the function here, which is the it's called search, where we get nims. So first let's handle some edge cases. So we have n equal to the length of the array here, and so we get a target value too, right? So we get a target value here, And so what we need to do is first check if the array is empty. In that case, there is no point in looking, right? We can just return -1. Otherwise, we check if it's sorted by already. So if it's sorted, then in that case, the first element is already smaller than the last element. That means it's sorted. So either so if it's sorted, then the first element would be smaller than the last element. At that point, we can just search in the entire array, right? So consider that we wrote this function that searches for a target value in the array. So we need to give it the first value, last value, and then the target we are looking for. And of course, we need to give it also the array. So nims start searching from 0 until the last value in the entire array, because it's sorted basically, and look for target. And then so this is one of the functions that I will write later, and then find the rotation index using the function that we just wrote. And so find rotation index. We'll need to give it and the target. And then once we have the rotation index, we can check if it's valid. So if it's not -1, so we check if it's if not in the range where it would be valid, then we can just return -1. Otherwise, we need to check whether we should look to the left or look to the right. How can we check? So if the target value is smaller than the first element, right? So let's say we are looking for 1, so it's smaller than 4. That means we should look at we should look in this portion, right? Because if it was bigger, we should look at this position, right? But we should look at this portion. But if smaller, we should look at this portion here, right? Because the pivot index contains the small, after the pivot index, the rotation index, we have the smaller values than the first element. And before the pivot index, we have the bigger values than the first element. So if this is, if it's less than nim0, then we need to go search left. Sorry, search right. Right of pivot. Otherwise, we should search left of pivot, right? And so this is how we are going to decide on which portion to look. So if target is smaller than the first element, that means that the target is on the right portion, right after the pivot, and so we need to search using our binary search method on the starting from the so we are searching right, so the lower value where we will be starting is at this rotation position, and the last value where we'll be searching is n-1, and so that means we start a rotation and end at n-1, and we'll be looking for target, right? Otherwise, we need to search on we need to go to the left of the pivot, so this portion here. And so let's go left of the pivot, which means return binary search on the array starting from the first index, because we are searching left, and ending at the rotation position, and we are looking for target. And now, so now that we have all of this, the only portion left is to define binary search function that just looks for a target value in a range, right? So we get names, we get the start of the range, the end of the range, and the target value. And so I already explained this exact method in this video that I will put in the video description, but I will just quickly do it here, where so we get so first we need to say, okay, while just the binary search template, low less than high, compute the mid, which is low plus high minus low divided by 2, and then check if, so the property or the predicate here is that names of mid, or p of x here is that array or names at x is bigger than or equal to target. And the thing is, first it will not be bigger or equal to target because the portion we are looking at is sorted, so we will get false value, and then we'll find the first element that is either equal to target or bigger than target, and after that we'll start getting true. And what we are looking for is this first value where it's true, but this first value just says that it's bigger or equal to target, so we are not sure if it's like equal, and so we need to check if it's a solution. If it's equal to target, then we return that index. Otherwise, that means that there is no value equal to target in the array, because this one is the first one that is true. All those before it are false. And so what we need to do here is just check that this is bigger or equal to target. This is our predicate, and if it is, we need to search left, because either what we found is here or what we found is here, and in both cases we need to look here. But we need to keep mid, because that maybe is the first element that we are looking for, and so we say high equal to mid, and otherwise we go, if it's false, there is no reason to go left. We know that these values are false. There is no value equal to target there, so we need to look right after the false value. And so to do that, we need to say low equal to mid plus 1. And then after that, we need just to check if it's a solution following our binary search template here, and if it is, return the index, otherwise return -1. And so to do that, we will check if basically if is equal to target, and if it is, we can just return that index, it's a solution. Otherwise, there is no solution, we can just return -1. And so now we have our template, so we have our solution. So first we do the search, where we check some edge cases like empty array, array is sorted, and then we find the rotation index, and accordingly we check if it's valid or not, and we decide whether to go look for left of the pivot or right of the pivot, and each portion of these is sorted, so we can just apply binary search on that range, and we decide using whether the target value is smaller than the first element. If it is smaller, then we need to look at the right portion. If it's bigger, we need to look at the left portion, and that's pretty much it. Now let's code this up on Leetcode and make sure it passes all test cases. Okay, so let's just quickly write what we just saw in the explanation and make sure it passes. And so the first thing we needed to do is just check some edge cases, right? And so first let's just say this is the length, and first check if the array is empty, then the value is for sure not there, so we need to return -1. And after that we check if it's already sorted, right? Which means that the first value is smaller than the last value. And so basically this means already sorted. And at that point we can just binary search on the entire array. And so we need to define here a function that looks for a target in some range. So the range would be represented by this. And after that, we need to do the first step, which is finding the rotation index, right? And so that is a function we defined also, right? That looks for the rotation index. We already have names and target here in the outer scope, so no need to pass them here. And now we check if that rotation index is valid. So that's when it's bigger or equal to 0 and less than n, so it's a valid index. If it's not valid, then we return -1. Otherwise, we decide whether to look left of the pivot or right of the pivot, depending on whether the target value is smaller than the first element. If it's smaller than the first element, that means it's in the right portion of after the pivot, or from the pivot to the end. And so to do that, we just we search in that range because we know it's there. If at all it's in the array, and so we return searching from the rotation index all the way to the right. Otherwise, it's on the left portion, so we can just return binary searching from the first position. Sorry, otherwise it's on the left, so we need to binary search from the first position to the rotation position. And now we need to define first our binary search, with just normal binary search. So while low is smaller than high, we compute the mid, so that's low plus, and we do the checking if the predicate is valid, and so that's by checking that number at mid's position is bigger or equal to bigger or equal to target, right? So we are looking for the first value that is equal to target, right? And so here, if it's bigger or equal, then that's a true. So to find either that value is the first value or there is another true before it, and so we need to go left, but keep that mid in the search space, because that's maybe the answer. Otherwise, we encountered a false, and so we need to search on the right, because if we are going to find a true, it would be after a false. And so we will say low equal to mid plus 1, and here we check if it's a solution. If a solution, return low, else return -1, because that means there is no solution, right? So checking if it's a solution is just checking that the value at that position is really equal to target, and at that case just return, otherwise return -1. Now let's find the rotation index, which same thing, we need to initialize low to 0 and high to n-1. We are going to search for the rotation index in the entire array and do the template for binary search here. We will need to take this to compute the mid, and then do the predicate that we defined, which was that the pivot index or the rotation index has to be both smaller than the first element and smaller than the last element. And so if it is, then we are looking for the first true, the first element that verifies this condition, that's the pivot. So in the same way as we did before, we are going to assign this to mid, because maybe it's the first, but maybe not, maybe there is a true before it. Otherwise, we need to look right, because we found a false, as I said in the explanation, so we need to look right to see if we find the true value. And so that would be mid plus 1, and here we check if it's a solution by just checking if either it's like sorted in ascending order, so the pivot position would be the first element, or it's sorted in descending order, so the pivot would be at the last position, or it's actually the pivot is actually in the middle or somewhere in the array, not in the boundaries. And in that case, it should be both smaller than what's before it and smaller than what's after it. That's the definition of the pivot. There are no duplicates in the array, so I don't need to check for equal, but if there were, I may need to. And so I return the first element, the lower element, otherwise I return -1. And that's pretty much it. Now we have our temp. So first we find the rotation index, then we check if it's valid, and we decide whether to go left, look left, or right. If it's smaller than the first element, we need to look right. If it's bigger, we need to look left. And here we define both our binary search usages. And so that's pretty much it. And so you can see here, because we are doing one find rotation index and one binary search at most, like either this one or this one or this one. So the time complexity here is, we do at most 2 binary search, right? So at most 2 binary searches. So this means that our time complexity is n log n plus n log n, right? So that means in terms of O, it's just O of n log n. And so we actually have something that matches what the problem is saying, to give a solution of order of O of n log n. And now we can run this and see if it passes all test cases. Okay, so looks like it does pass all test cases. This problem can also be solved using one pass binary search that you can look into, but this is, I think, easier to understand. Yeah, so that's it for this problem. Thanks for watching, and see you next time.